Hello and welcome to G Fun Facts Online. Today we're venturing to the coldest, most remote continent on Earth to uncover a secret world hidden beneath miles of solid ice. For most of history, Antarctica was just a vast, white blank on the map. But what if I told you that beneath that ice lies a landscape of mountains, valleys, and canyons so enormous they make the Grand Canyon look modest? And what if I told you that the deepest point on any continent on Earth isn't the Dead Sea, but a chasm hidden under an Antarctic glacier, plunging an incredible 3,500 meters or 11,500 feet below sea level? This is not science fiction. This is the story of Antarctica's colossal canyons, a hidden world that is actively shaping the future of our planet. For centuries, our view of Antarctica was limited to its surface. The heroic age of explorers like Scott and Shackleton was about conquering that surface, a race to the South Pole. The landmass underneath was a mystery, assumed to be a relatively flat, single continent crushed by the weight of its ice. That all began to change in the mid-20th century. The real revolution came with a technology called ice-penetrating radar. Imagine being able to see through solid rock, but in this case, the rock is kilometers-thick ice. By mounting radar systems on aircraft and flying back and forth across the continent in vast, systematic grids, scientists could send radio waves down through the ice. These waves would bounce off the bedrock below and return to the plain. By measuring the travel time of that echo, scientists could finally map the true shape of the continent hidden beneath the frost. And the picture that emerged was stunning. It wasn't flat at all. It was a continent of immense mountain ranges, sprawling basins, and deep, deep valleys. The heroic age of reaching the pole had given way to a new heroic age, the quest to understand what lies beneath. While airborne radar is the workhorse, mapping a continent the size of the US and Mexico combined is a monumental task. To get the big picture, scientists turn to space. Satellites, using altimetry, measure the height of the ice surface with incredible precision. A giant mountain range buried under the ice will cause a subtle, gentle bulge on the surface, while a deep canyon can create a slight depression. It's like finding a person under a thick blanket by looking at the lumps and dips. Other satellites measure gravity. A dense mountain range has more mass and pulls on the satellite a tiny bit more strongly than a deep canyon filled with less dense ice. By mapping these tiny gravitational variations, we can effectively weigh the continent and infer the shape of the rock below. All of this data, from planes, satellites, and on-the-ground seismic surveys, is fed into incredibly sophisticated computer models. The latest and greatest of these is called Bed Machine Antarctica. It doesn't just compile data points. It uses the physics of ice flow to fill in the gaps. By knowing how fast the ice is moving on the surface, scientists can calculate the volume of ice flowing through a particular channel, and from that they can infer the shape and depth of the valley carrying it. It's this combination of technologies that has allowed us to create a gallery of giants. Let's start deep in the interior, near the South Pole. Here, scientists found a series of massive troughs, the largest of which is the Foundation Trough, stretching over 350 kilometers long and 35 kilometers wide. These canyons act as massive ice highways, funneling ice from the high, stable East Antarctic ice sheet towards the much more vulnerable West Antarctic ice sheet. Their discovery was a surprise, revealing a connection between the two ice sheets that could have major implications for future ice loss. But the most jaw-dropping discovery came from the Denman Glacier in East Antarctica. Using the bed machine model, scientists realized the canyon beneath this river of ice was far deeper than anyone had imagined. It plunges to 3,500 meters below sea level. To put that in perspective, the lowest exposed land on Earth, the shore of the Dead Sea, is only about 430 meters below sea level. The Denman Canyon is 8 times deeper. The reason it was hidden for so long is that its walls are so steep, they created a confusing mess of echoes for the airborne radar. obscuring the true bottom. Only by calculating the immense volume of ice flowing through the glacier could scientists deduce that the canyon had to be this deep to contain it all. And it doesn't stop there. In one of the last, truly unexplored parts of the continent, a region called Princess Elizabeth Land, satellite data hints at what could be the largest canyon system on Earth. Faint features on the ice surface suggest a network of canyons over 100 kilometers long that's significantly longer than the Grand Canyon and up to a kilometer deep, all connected to a suspected subglacial lake larger than many cities. And the canyons aren't just on land. A recent detailed map of the Southern Ocean floor revealed a network of 332 submarine canyons carved into the continental shelf. That's 5 times more than we knew about before. Some of these underwater valleys plunge to depths of over 4,000 meters, acting as the primary conduits between the deep ocean and the Antarctic coast. So how did these colossal features form? It's a story written over millions of years. Some of these canyons likely began as ancient river valleys, carved back when Antarctica was a green continent. Tectonic forces also played a huge role, creating deep rift valleys and weaknesses in the crust that would later guide the flow of ice. Then, about 34 million years ago, the ice came. Glaciers are nature's bulldozers. As they flow, they pluck away huge blocks of rock and grind down the bedrock with embedded stones, carving deep U-shaped valleys. The fastest flowing parts of the ice sheet, called ice streams, are incredibly powerful erosional forces, and they've been deepening these ancient valleys for millions of years. This brings us to the most critical question: why do these discoveries matter so much? Because these canyons are not just geological relics, they are active players in our planet's climate story, and they could be the Achilles heel of the Antarctic ice sheet. The submarine canyons act as direct pipelines for warm ocean water. Deep in the Southern Ocean, there's a layer of relatively warm, salty water called circumpolar deep water. The canyons provide a pathway for this warm water to flow up onto the continental shelf and attack the base of Antarctica's floating ice shelves from below. This basal melting is one of the biggest drivers of ice loss. As the ice shelves thin and weaken, they lose their ability to hold back the glaciers on land, which then accelerate their flow into the ocean, raising sea levels. The Denman Glacier, with its record-deep canyon, is a terrifying example of this. The bedrock beneath it has what's called a retrograde slope, meaning it gets deeper the further inland you go. This is a recipe for instability. As the glacier's edge retreats into this deepening canyon, it exposes a thicker and thicker face of ice to the warm ocean water, creating a feedback loop of runaway melting. The Denman Glacier alone holds enough ice to raise global sea levels by 1.5 meters, or nearly 5 feet. Understanding the exact shape of these canyons is therefore absolutely essential for our climate models. For years, the unknown topography beneath the ice was a huge source of uncertainty in sea level rise predictions. With this new, detailed map, scientists can finally build more realistic models of how the ice sheet will behave in a warming world, helping us understand which areas are most vulnerable. But the story has one more incredible twist. Where there is water, there is the potential for life. Scientists have now discovered over 400 lakes of liquid water buried beneath the ice sheet, kept from freezing by the immense pressure and a trickle of geothermal heat. For a long time, these were assumed to be sterile, but in 2013, a team drilled 800 meters through the ice into Lake Whillans in West Antarctica. The water samples they brought back were teeming with life, nearly 4,000 different species of microbes. In the perpetual darkness beneath the ice, life can't use photosynthesis. Instead, these organisms use chemosynthesis. They literally eat rocks for breakfast. The constant grinding of the glacier on the bedrock exposes fresh minerals, and these microbes derive their energy from chemical reactions with those minerals, like iron and sulfur compounds. This discovery is profound. It proves that complex ecosystems can thrive in one of the most extreme environments on Earth, completely cut off from the sun, and it has fired up the field of astrobiology. Icy moons in our solar system, like Jupiter's Europa and Saturn's Enceladus, are thought to have vast liquid water oceans hidden beneath their ice shells. The conditions there could be very similar to Antarctica's subglacial lakes. If life can thrive by eating rocks in the dark beneath Antarctica, perhaps it can do the same in the hidden oceans of these distant worlds. Our exploration of this hidden realm has only just begun. Scientists are planning new expeditions to confirm the scale of the canyon system in Princess Elizabeth Land. They're developing cleaner, more advanced drills to sample more lakes, perhaps even the legendary Lake Vostok, which has been sealed off for millions of years. And they're building autonomous robots, or cryobots, that can melt their way through the ice to explore these environments without the risk of contamination. The colossal canyons of Antarctica have transformed our view of the White Continent. They are a reminder that even in the 21st century, our planet still holds secrets of an epic scale. They are a critical piece of the climate puzzle, a key to understanding our future of rising seas, and they are a potential cradle for life in the extreme, offering clues in our search for life beyond Earth. As we continue to chart this hidden world, we are not just drawing new lines on a map. We are gaining a deeper understanding of the powerful forces that shape our fragile planet and the crucial insights we need to navigate our shared future. Thanks for listening to Fun Facts Online.